Proving a geometric figure is a rectangle. Today I am learning the properties of a rectangle so that I can prove that a geometric figure in the coordinate plane is a rectangle. I will know that I have it when I score an 80% or above on my practice assignment. The properties of a rectangle are: the figure will have four sides, opposite sides are congruent, and by opposite sides we mean sides that are across from each other. Opposite sides are also parallel. All four angles are right angles. Diagonals are congruent. And we know diagonals are formed by the segment drawn from opposite vertices. And also the diagonals bisect each other. And by bisect, we mean cut in half. So for this example, the first thing we will have to do is prove property 1. The figure has four sides. In order to do that, we will count the number of sides. 1, 2, 3, 4. If you count four sides, then the figure has four sides. So to answer the question, does the figure have four sides? Yes. Let's prove property 2. Opposite sides are congruent. What we will do is calculate the length of each side by counting or using the distance formula. Now, because none of our sides are vertical or horizontal lines, we will have to use the distance formula for each side. So the first thing that we want to do actually is to identify what our opposite sides are. Remember, we have already looked at that. We've already been told, on the first slide, that opposite sides are across from each other. So I'm just going to highlight so you can see your opposite sides. So we know we have ZY and WX, and we also have YX and ZW. So now that we know what our opposite sides are, we can go ahead and find the length of each. The last thing that we need is the actual ordered pairs for each point or vertex. So Z is 1, 6. Y is 3, 7. 5, 3. And 3, 2. Now that we have found that, go ahead and pause your video. Take the time to find the distance of each of the line segments and press play when you are ready to see what you should have gotten for the length of each line segment. So we have found the length of each line segment. Now let's see if our opposite sides have congruent lengths. So opposite sides ZY and WX, they have the same lengths, meaning they are congruent. Opposite sides YX and ZW, they have the same length, meaning they are congruent. So to answer the question, are opposite sides congruent? Yes. All right, now let's prove property 3. Are opposite sides parallel? So first, what we will need to do is find the slope of each side using the slope formula or counting rise over run. I am going to use rise over run because this graph is pretty easy to view, and I can easily count rise over run. Now, whenever I have a graph that is hard to look at, either it's blurry, it's too small, that's when I would use slope formula just to guarantee that I am getting the correct slope. So again, before we identify our slope, let's go ahead and identify our opposite sides. And we did do this when we proved property 2. But I'm just going to highlight once more our opposite side so there's no confusion. So we have opposite sides ZY and WX, And we also have YX and ZW. Okay, and I just noticed something on here. These should say M because we are finding the slope and not the distance. So please do make that edit on your within your notes. Okay, so let's go ahead and find the slope of each line segment. So looking at ZY, I would rise 1, which is go up 1 and then to the right 2. So that's a positive 1 over 2. For YX, I would go down 1, 2, 3, 4, right 2. That's a negative 4 over a positive 2, and that would simplify to be negative 2. For WX, I would go up 1, right 2, positive 1 over 2. And then for ZW, I would go down 1, 2, 3, 4, right 2. That's a negative 4 over positive 2, which simplifies to be negative 2. So now we know that ZY, we got 1/2. WX, we got 1/2. YX, negative 2. ZW, negative 2. So what we should be looking at is if the opposite sides have the same slope, they are parallel. This pair of opposite sides has the same slope. This pair of opposite sides has the same slope, meaning that these sides are parallel and these sides are parallel. So our opposite sides parallel? Yes. Let's prove property 4. All 4 angles are right angles. So what we would need to do is find the slope of each side using the slope formula or counting rise over run. So we have already found the slope of each side. So I'm just going to write in what we just found. And these were negative 2, I believe. Yeah. Okay. So what we're going to figure out is if the consecutive sides have opposite reciprocal slopes. So before we go any further, let's go ahead and identify our consecutive sides. Consecutive means right beside each other. So side ZY and YX are consecutive. YX and XW, XW and WZ, and WZ and ZY. So we have identified our consecutive sides. Now let's write in the slopes. ZY is 1/2. Where was the other ZY? Right here, 1/2. YX is negative 2. YX, negative 2. WZ, negative 2. And what did I miss? WX is 1/2. Okay, so now if consecutive sides have opposite reciprocal slopes, then the shared angle is a right angle. So are these opposite reciprocal slopes? Yep. Opposite reciprocal, opposite reciprocal, and opposite reciprocal. So now we can answer the question, are all 4 angles right angles? Yes. Property 5, the diagonals are congruent. So what we would need to do is calculate the length of each diagonal by counting or using the distance formula. When we say diagonal, that is the line drawn from each opposite vertex. So our diagonals are YW and ZX. So we notice that YW is a vertical line. So all we have to do is count 1, 2, 3, 4, 5. So the length of YW is 5. So all you have to do is find the length of ZX using the distance formula. So Z we know is 1/6, X is 5/3. So now go ahead and take a moment to find the length of ZX using the distance formula. Pause the video and only press play when you're ready to see what you should have gotten. Okay, what you should have gotten for ZX is 5. So what we notice is that our diagonals do have the same length. So are the diagonals congruent? Yes. All right, I believe we just have one more property. Property 6, the diagonals bisect each other. So what we will need to do is calculate the midpoint of each diagonal. So let's just remind ourselves that our diagonals are YW and ZX. In those ordered pairs, I'll put those back really quickly. 3, 7, 5, 3, and 3, 2. So what we are going to do is use the partitioning line segments formula, and we'll use the fraction 1/2 because that is what you do when you're trying to find the midpoint. So what I need you to do is go ahead and pause the video, use your partitioning line segments formula, and find the midpoint of each diagonal. Press play when you're ready to see what you should have gotten. So here's the work for the partitioning line segments. And the midpoint that you should have gotten was 3 and 9/2. So if the two diagonals have the same midpoint, then they bisect each other. So because these have the same midpoint, we can answer the question, do the diagonals bisect each other? With the answer, yes. So now we can answer the final question if this is here's another typo that should say rectangle. So is the geometric figure a rectangle? Did it have 4 sides? Yes. Opposite sides were congruent. Opposite sides were also parallel. All 4 angles were right angles. The diagonals were congruent, and the diagonals did bisect each other. So is the geometric figure a rectangle? Yes.